So I'm Alex Debrie. I'm the author of the DynamoDB book and just do a lot of work with DynamoDB. I'm an AWS data hero for my community work with DynamoDB, and then just do consulting, training related to DynamoDB in the community. Trilogy, I think, is a high performance place, and it just has people that care about the work and care about doing these design reviews well, making sure the engineering stuff makes sense, making sure they understand the product and business needs too, because I think sometimes you get to places where engineers want to focus so much on just the core engineering problems. They think that's the fun part. But if you're not tying it back to solving a customer's need and understanding how it works with the product and understanding those trade-offs, you might be building something that's not super useful.
Hey guys, I'm Badri Varadarajan. I live in San Jose, California. I'm portfolio CTO at Trilogy. That means I build a bunch of products, including, most relevant to this conversation, the next generation of CRM on DynamoDB.
Hey, I'm Pawan Kumar from Bangalore, India. SVP of Engineering, responsible for building the cloud CRM product and anything related to webscale product lines.
So we have something like 4 or 5 different CRM products in our portfolio, and they're all on-prem. We're trying to modernize them. And one part of that is just getting them to scale. A problem with lots of our products right now is they're on-prem. It's very, very hard to scale them to larger customers. But the other part of that is also scalability and complexity, not just in terms of users accounts and so on. So we want to have lots of customization capabilities. So more or less the whole point of modernizing it is to scale in these 2 dimensions.
Yeah. Absolutely, yeah. And I think that's interesting, where some of these more modern technology comes in, where these products are on-prem previously. You know a lot about how that works, what people are using them for, what kind of customizations they want to use. But then moving it over, replatforming onto AWS, onto DynamoDB gives you that scalability and ability to reach more folks more easily.
Yeah, the other important aspect is when we're building these platforms, you would want some kind of a common base you want to build all of these on, rather than repeating the same thing again and again. And hence, the concept of application scaling using a platform is also important.
Yeah.
We will touch upon those topics as well.
Yeah.
Whether you want to pick up something on how open apps as a base is kind of bringing the cloud CRM.
Right. So we talked a little bit about just leading off of what Pawan just said. So CRM was one part of this. So what we also realized is we had a whole bunch of other products in the portfolio which kind of had the same story, right? I mean, on-prem, we really want to modernize it. We really want to handle scale and complexity. But then these were different enough at the application layer that we had to sort of think through what it meant to scale just the storage and access layer, if you will, and then still be able to innovate at the application layer in an application-specific way. So we have this internal project called Open Apps, and so that's the storage and access layer, if you will, and then plugins or application-specific logic to make it behave like a CRM or make it behave like a BSS.
Nice. And how's that project coming along? I mean, do you have a few different apps working on it? Like what stage is that project's in?
Yeah, we have CRM is the app that's furthest along. We've actually built it and shown crazy amounts of scale. I mean, probably we can handle truly web scale accounts and subscribers and whatnot. And we also have the same thing going on with the BSS project. So we're building something for the telco vertical, which is like super interesting. We also have some deep application logic in charging, which is sort of adjacent, also built on DynamoDB. So one of the things that would be interesting to talk about is like how DynamoDB really achieves that sort of scale and what does it give you and so on.
Yeah, absolutely. I love to talk. I mean, I love DynamoDB. I think what's so interesting about it is you see it coming out of Amazon.com's experience, scaling these applications to web scale, like you're saying, scaling Amazon.com retail, whether that's the shopping cart, the fulfillment, whatever that is, scaling those up and getting it to really truly web scale. DynamoDB being a huge portion of how that works. And I think a thing that's interesting is they, relational databases great at a lot of things, but they wanted to rethink some of the constraints of databases, some of the features of databases to really enable that web scale. What features do we truly need? What access patterns do we really need to support? And then what ones can we not use because maybe they don't scale as well? So, interesting thing about Dynamo, it scales really well horizontally. There's an important concept called the partition key, going to be included on all your items, going to help distribute that data across machines, allow you to scale up really well horizontally as you grow. giving you consistent performance as you go. But I think as part of that, then they're also removing some features like joins and aggregations that maybe don't scale as well because you end up having these unbounded queries, right? They can't know in advance how big that query is going to be and give you that same consistent performance capabilities there or guarantees around that. So just some of the things they're doing there, and then also just the fact of Dynamo being a fully managed service where you really just don't have to think about as much, and you don't have to do as much DBA type maintenance with DynamoDB. I think it's pretty interesting. It lets your team focus on these cool abstractions, lets you focus on delivering more features and more stable features and things like that, rather than thinking about your database all the time.
And picking up the topic like partitioning you just mentioned, for one of the project we're kind of trying to test the scale of how we can store the data. Then we hit upon that kind of a partition limits, and we have this, let's say, WCU limits in terms of kind of hitting one partition, not able to scale beyond 3K and all of that. So I think we had some interesting insights around like if the total data storage on a specific partition crosses certain limit, you start seeing a sudden increase in performance because internally maybe AWS is trying to kind of shift that to another partition.
Yeah.
Anything we would want to kind of discuss on the topic, maybe insights, what you learned from that discussion we had?
Yeah, absolutely. That was super interesting. I mean, just as a little more background there, with DynamoDB, they're going to split your data into those partitions we're talking about. Generally, those physical partitions are going to be about 10 gig in size, and then they'll sort of split your data up. But they'll also split it up based on if you have really hot access patterns on a particular partition. So if that data size grows, or if it's just accessed a lot, they'll split it. And one of the team members did like a really interesting investigation on, hey, let's write a bunch of data into it. Let's write it at really high load, read it back out. What does that partition splitting look like? How does our capacity change as we sort of scale that up? And what can we count on from DynamoDB? And you find out, the published limits they give you on DynamoDB, those are great and pretty solid, and you're going to get those. And then also, sometimes as a bonus, as an extra guarantee, they'll help you by splitting a partition and sort of giving you more capacity. So sometimes you can burst beyond that if you need to.
Yeah. And this is interesting where like we're able to kind of push that limit a little beyond than what is kind of officially documented.
Correct.
Yeah.
And that kind of gives that extra edge in terms of kind of importing a lot of data into the system initially, because for one of the MWC demos, we had to kind of push in like 8 billion entries into that.
Something like that, yeah.
And this really helped into kind of pushing that boundary a little bit more.
Yeah. One other thing you mentioned, Alex, is this whole thing about DynamoDB forcing you to do two things, right? Think about your data access patterns first, and also limiting what you can do. That was sort of a key insight learning for us is, okay, it forces us to think about this, but also sort of use DynamoDB as our landing spot. So one of the things that we talk about when we do scale is, when we're talking about why we scale these things, is we're trying to liberate data from where it is sort of locked into on-prem systems, and there's a ton of it, right? We have something like, as I said, 5-6 CRMs. So this whole thing about DynamoDB also being nicely connected to the rest of the ecosystem, if you want to talk a little bit about that.
Yeah, sure. So I think like you're saying, like DynamoDB integrates pretty well with other AWS services. Dynamo is going to excel at OLTP access patterns, right? Known access patterns, hot access patterns where in your CRM, someone's trying to get a list of customers or leads or users or something like that, known access patterns. But then you also have, OLAP type access patterns or analytical access patterns. DynamoDB will help you with some of that stuff. There's you can quickly export all your data to S3 and then run Athena queries on it, right? Which is like this big distributed map reduce on data in S3 and allows you to write SQL on S3 files. So you can do analytics that way with Athena. You can also enable, DynamoDB streams, which gives you this change data capture, gives you this change log where you enable DynamoDB streams on your table. Every time you write into your table, whether that's an insert, an update, a delete, anything like that, it's going to drop a record in that stream and you can process it, whether you want to pump it into an analytics system, whether you want to fan it out and send it to other, for other microservices to subscribe to and react to, whether you want to maintain aggregations within your own service, something like that. A lot of interesting capabilities there and unlocks the rest of the AWS ecosystem for you.
Right, yeah, and we are playing with Kendra right now. We're sort of trying to do some semantic search on text as well. Yeah. It's been interesting, sort of we're trying to push the boundary of another system within AWS, I guess. Yeah. But this whole thing you said about DynamoDB sort of it integrates with AppSync. We're big on GraphQL and sort of flexible access layers. So that whole package really works with, and when you're trying to scale, again, complexity, because you want to do lots of different things in different applications. I think some of the application-specific logic is interesting. You want to sort of talk about how CRM is maybe different from BSS a little bit.
Yeah, so essentially, like the data model which is required for a typical BSS is like a way different from, let's say, a typical CRM type data model, right? I'm trying to build two different, like a siloed applications on kind of a system like this is like waste of resources and duplicating a lot of data and all of that. But I think we talked about something called an open apps layer. We kind of have a common base layer in which you can build these applications on top of it. And as a customer, you can define what data model you would want on that. The flexibility of providing what data model you would need, and then having automatically generate these code which is required for basic, like the CRUD operations like get, put, delete and everything would really help kind of kickstart the app code base, and then you can start doing something on top of it, right? So you don't need to worry about the basic scaling, the best practices about how the code needs to be written, how AppSync needs to be tuned. All of that is taken care by this layer, and hence the application can only worry about what they need to do on that layer than worrying about the scaling best practices.
So sort of what that translates to what Pawan's team built is this kind of slot machine. You give it a data model, and it actually generates a whole nice backend for you. It's like a DynamoDB with a GraphQL endpoint, and that thing also uses DynamoDB streams to put data into S3, and essentially you get this package, and then you start customizing it with application-specific logic. One of the things there with DynamoDB that was sort of super interesting for us was this whole indexing patterns and all the patterns that you sort of came up with in terms of one-to-many relationships, many-to-many relationships. You want to talk a little bit about that?
Yeah, sure. I'd say, DynamoDB has a lot of great properties like we're talking about before around scalability, around how well it works with serverless and AppSync and things like that. But modeling with Dynamo, very different than modeling in a relational database. And I think a lot of people have years and years of experience of modeling with relational. Sometimes they'll try and bring that to Dynamo, and it just works in a different way, and they're not getting all the benefits of Dynamo if they're sort of modeling in a normalized relational way in their DynamoDB tables. So, a few things that are interesting with Dynamo, you're going to probably denormalize your data a lot more. You might duplicate some information onto multiple items to save you from making an additional read request up to a parent item or something like that. You might have, rather than have a separate table for a many-to-many relation, maybe you just duplicate it onto an item and just sort of have that relationship represented on an item itself, on its parent item, and hold it that way. You can also sort of pre-join type data, right? If Dynamo doesn't have joins, but you can sort of emulate joins at write time that allow you to, when you're doing a read, your data is already joined in a nice, efficient way. You're basically doing, one disk seek rather than having to sort of jump around your disk and things like that. So a lot of interesting different patterns that, are going to feel really weird to you if you're coming from that relational world. But the great thing about Dynamo, I think, is that it exposes all these trade-offs to you that are sort of hidden when you have this relational database. You have a query planner that works well at sort of normal scale, but once we get up to web scale, planet scale, whatever you want to call it, right? It's not going to work as well. You're going to find your performance gets slower around some of these access patterns. Dynamo is going to expose that to you more upfront, make you think about those trade-offs upfront and explicitly plan for those. And then you can do interesting things like the tests around the partition limits and things like that, and say, hey, how do here are my assumptions, here's my data model, how does that work in reality? Is this working and scaling as well as I think it will? So pretty interesting, I think.
From a DynamoDB point of view, like since we kind of keep all the data in that place, can be streamed out to multiple other destinations, I would call it. Mm-hmm. From product point of view, Badri, I think we had seen like you could go to Pinpoint, you could go to, let's say, recommend or anything. Like a lot of use cases which can kind of blow up because we're keeping the data in DynamoDB. Yeah. Because keeping a central kind of a data store kind of a thing. Right. How is that panning out from a product vision point of view?
That's an interesting thing, right? So when we are sort of moving from on-prem to the cloud, or indeed even from another cloud-hosted CRM, one of the things we can do is to build an application while still letting people use their CRMs, using their existing interface for their day jobs, right? So there's an on-prem CRM, we just hover up all that data into the cloud, and now we can quickly put together a customer outreach application or a marketing application. Using, again, as you said earlier, DynamoDB ties up nicely with lots of other services. So we can sort of tie it up with Pinpoint, do an outbound marketing application. We can tie it up with Kendra, do semantic search, all kinds of interesting things. Outbound marketing has been sort of pretty interesting for us. It was essentially what happened is there's a set of users using CRM, and then just their marketing department gets an application that's separate that they can use to do campaigns.
Yeah.
And monitor them and scorecard them and so on. So that becomes really interesting as a use case.
Yeah, fun to see all the different things you can do out of that. What about search? Are you indexing these in like search engines or like Elasticsearch, OpenSearch, something like that?
Yeah. So essentially, we do the indexing using the patterns to do the hot searches, the most common ones, and then use OpenSearch for say text search and sort of as a catch-all as well. You can do interesting things with filtering, with arbitrary filtering. But that's one of the bets that we're making is sort of the right tool for the job, as Andy Jassy said. Last reInvent. So essentially, you get this data in one place and then fan it out and do whatever it is tool that you need for that particular application. And the idea of this open apps thing that Pawan mentioned is that it's a Lego. You can sort of build applications as you go along. So you want to build search, you just stream it to Elasticsearch and then build a search application on top of it. And again, that's where GraphQL helps. We sort of stitch together different GraphQL endpoints as well. You sort of get a GraphQL endpoint along with a search app or something.
Cool. Yeah, I mean, one thing I love about open apps, to take another AWS executive, like Werner Vogel's always talking about reducing undifferentiated heavy lifting. And it seems like that's what open apps is doing, is getting you set up with these different tools that are common across different applications, giving you search, giving you Kendra, Pinpoint, whatever you need if you need it, as well as just being built on DynamoDB and scalability that way. So pretty cool.
Obviously, we're betting on noSQL for scale. If you could talk a little bit about some of the choices, some of the outcomes that would be different between, say, a relational database and DynamoDB. Obviously, in the beginning, it's all going to work out. But when we are at truly web scale, like when you had this nice curve, I think, in your presentation about how you can reach the top, right? Yeah,
sure. I think, just generally what you see with relational databases, they're going to work really well when you're testing locally. You're in your staging environment, early on in your application lifecycle when you have plenty of RAM, plenty of memory to fit all that data in memory. But as you start to get more and more data, as you start to get more and more concurrent connections and queries against your database, you see that performance curve start to slow down over time. That latency gets higher and higher, and it becomes difficult to know how to debug that. Maybe at the beginning you can add more indexes or you can increase your instance size, but at some point, you've got all the indexes you need, you're really maxing out your instance size as big as you can get, and you're still having issues scaling there. And it's just sort of the fundamental nature of how these relational databases go, where generally they need to be sort of centrally located on one instance. You're just sort of vertically expanding that rather than horizontally partitioning it. DynamoDB is going to be different. It's going to sort of partition this across all these different partitions, keep those, again, around 10 gigs of data. So even if you have a 1 terabyte, a 10 terabyte table, that request comes into DynamoDB. It's going to look at that partition key and immediately find out which partition you're going to. And immediately you've reduced your 10 terabyte table down to a 10 gigabyte partition, where you're searching around in that a lot quicker to work in that, a lot more consistent scaling as you go, because they can just add more partitions as you go and give you that. And a few other things about Dynamo, I think if you work with most databases, they'll just sort of take on load until they start to slow down or they fall over or what happens. Dynamo is going to prevent you from doing that in certain ways. So they have these limits, whether it's an item size limit or the page size limit on a query or a scan operation or the partition throughput limits. They put these limits in place that say, hey, you can go here and no further, because either we can't guarantee consistency of performance on response time or consistency of response time on this particular partition, right? We can't handle that much load. So they'll sort of throttle you there or limit you in some way. It's nice to have these, I would say, clear, harsh, bright lines in advance where you can model around those as an engineer and think, okay, I can't go beyond that. Am I going to need to go beyond that? If I do, I think about that up front rather than 2 years into my application, I have 8 billion records in there, and I need to figure out how to move stuff around to make it work now.
Right.
Yeah.
Actually, an interesting war story on that is there was another application built on Postgres, I think,
Yeah.
and essentially all that we knew was it was killing the database, and the architect who built it is no longer there, and so it's like there's some other DBA looking at all the queries and trying to figure out like which is the most damaging query, and it turned out it was just a cron job running, generating a report which nobody ever read. So it's like DynamoDB forces you to not do things like that. But can you talk a little bit about DynamoDB versus other NoSQL?
Yeah, sure. I think that's an interesting thing because you see, in the early mid-2000s, you saw these different NoSQL databases come out, whether that's DynamoDB, MongoDB, Cassandra, a lot of them based on similar principles. And I think on the front end, right, they're all going to use that partitioning principle where they can horizontally scale by using some sort of partition key or shard key to spread your data out across these different partitions. So a lot of them have that same basic principle. I'd say the most interesting difference, I think, is between DynamoDB and MongoDB, right, which are probably two of the more popular NoSQL databases, and just a total difference in data modeling philosophy aside from that partition key. So DynamoDB is going to be kind of strict, kind of restrict you and say, even if you want to do something that might feel good now, sorry, you have to eat your vegetables, you have to think about how to think about scaling up front. We're not going to let you do the wild and crazy thing because we don't want you to get 2 years down the road, 3 years down the road, and now it doesn't scale anymore. So we're not going to let you do that. It means it's a little more inflexible user experience, and you have to learn more about modeling early on, but it's going to work longer, and I think in the long run. I think if you contrast that with MongoDB, a lot of the same partitioning principles, but they're a lot more flexible on what they'll allow on data modeling patterns and re-indexing stuff. And if you just think about both of these are going to have for your primary access pattern a partition key, a shard key to sort of distribute your data. And then both of them have ways to re-index your data to allow for additional access patterns. With DynamoDB, they're going to sort of repartition that data, re-index it onto different machines altogether. So you're going to pay that extra cost of having these different machines, but it's going to be efficient reads on those secondary indexes. It's not going to slow down reads and writes on your main table doing that because they've got separate hardware for that. With Mongo, by contrast, they're just going to re-index on those existing machines. And if your index doesn't use whatever your shard key is to initially distribute your data, now if you run a query, it has to hit every single one of your partitions, basically do a scatter-gather type operation to get all that data, come back, merge it together, and return it to you. It can result in sort of weird sorting or inconsistent results in some ways, but I think the trickier thing about it is you've lost some of the benefit of that horizontal scaling, right? Because if every query, or all those secondary queries are going to hit every node, even adding an additional node, it's already going to have this sort of baseline level of traffic just to handle those scatter-gather type queries. So it can limit your scalability there, where you have to scale horizontally, but also vertically to accommodate that.
Right.
Yeah. Just to add to that, I think kind of Dynamo forcing you to kind of think the vegetable example you get is a wonderful one, because the most common use case could be like, let's add attachments to this, add blobs to this field.
Yeah.
It's like hardly anything. Let's put a free-form blob into this kind of a thing. It's so easy to kind of fall into that pit.
Yep.
And then when you hit that 1 MB limit, they say like, no, this is not the right way to do that.
Yep.
Dynamo literally forces you to say like, no, it might look like very easy to do it right now.
Yep.
The moment your records go so huge, and all of these nodes and blobs kind of add into these layers, and then you start seeing scaling issues.
Yep.
Instead of realizing that quite late in the equation, that 1 MB limit would kind of force you to say like, no, let's not keep blobs into this and keep the blobs out somewhere else.
Yeah, exactly. And just expose it, like in terms of those limits, it's a great way to expose it to you. Also, you see it directly in your bill. If you start having these giant items and you're updating them, you're going to be paying more for your write capacity units. You're going to be paying more read capacity units. It's directly exposed to you rather than a more amorphous, like, hey, you provision some instances, maybe your CPU use is higher, maybe you need to scale up, but you can't really trace down where that came from. With Dynamo, you see, oh, we have these much larger items that now we're writing to a lot, and it's costing us in our main table, in our secondary index, wherever, and it's just like more directly exposed to you. You can feel that pain, and also if you solve that problem, you reduce that pain. You get the benefit of seeing that very very easily.
Yeah, Postgres war story again. We run this monster machine like 24XL.
Yeah.
We were doing this thing where we were upgrading from Intel to Graviton now. And then we realized when we were doing this, we're looking, okay, what's in this database? It turns out like 30% of this was blob.
Yeah, blobs and logs. I see it all the time. Yeah, huge stuff. And it's hard to investigate that stuff, and people don't, so they just scale it up. And then you're like, wait, why are we spending thousands and thousands a month on this giant database, and it's holding these giant blobs that are never even accessed, or things like that. So it just makes that more apparent.
Yeah. You want to talk about that aggregate thing that was an interesting pattern that you had of trying to keep counts of things. Thought that would be interesting to get Alex's opinion on.
Yeah, so I think one other thing what we're looking at saying, like when you have these large tables, like there is no concept of default total count in DynamoDB, and hence like the only other solution could be like just stream these to maybe Elasticsearch or whatever and kind of get those counters.
Yeah.
The other way to kind of say is like if you want to run filters on top of it, then these aggregate count becomes even more complex. Let's say let's take an example of I want tickets which is pending count, and I want a total ticket count as well. And hence, it's not just you're asking total count, you're also asking a count on a filter.
Yep.
And then it becomes like a little bit more complex in DynamoDB.
Yep.
But yes, I mean, there are ways to kind of handle it. Maybe you could touch upon.
Yeah, it's interesting. And the thing is, like, if you're using something like Postgres or Elasticsearch, you might just throw in these sort of aggregations counts where this thing is true, and also count just total tickets and things like that. Again, going to work well for you in test and maybe for the first 6 months, but you start to get more and more tickets in there. If you have those aggregations in Postgres or even Elasticsearch, I see a lot of people do the same thing there. The cost can be hidden from you for a long time about that, and it's not really apparent how much that's costing you eventually. Where with Dynamo, there's no built-in aggregation function. So you're gonna have to do the work of sort of reading that data yourself and calculating that aggregation, or maybe doing some pre-aggregation in some way. If you know this is an access pattern for you, maybe you can aggregate that and reduce the space for you to do that. So again, with Dynamo, it's shifting left and making you think about these scaling problems, whether that's aggregation, whether that's total data, whatever that is. It's making you think about that up front and think about it that way. How do I handle this? Rather than sort of relying on the query planner and finding out later on you have some problems. So yeah, I'd love to talk about what you all think of like the future of scalability is. I'm pretty excited about, I think in the near term, just like more increased adoption and awareness of DynamoDB and its capabilities, and you're seeing people, adjust to the different data modeling patterns there, and I think getting some of those benefits. So that's interesting to me in the near term. I think longer term, you still see some areas where those additional sort of ancillary access patterns, whether that's search, whether that's aggregations, whether that's internal analytics, I think just some of the tooling around that stuff to make it easier to get that in a more real-time way without having to, build your own streaming type thing or something on that. That's what I'd really love to see out of Dynamo and just enabling those and making them easier. So what about you?
Right, yeah, I mean, that's spot on. Essentially for us, we are hoping that we are building this stable base and we're going to spend the next 10 years innovating in the application layer. But obviously there's a big learning curve to get the foundation right, to make it support all kinds of things. And getting customization right is something very important for us. Obviously, we're making a big bet, not only in terms of like customizing CRM, but building different applications on top of this. So, like you said, the big challenges we see are how easy is it to get data out into something else that you need for your application. So that said, I mean, with all the testing that you alluded to it earlier, we're very happy with sort of the scale of DynamoDB as the storage layer itself. That I don't think is going to be a problem. The problem is going to be like how well can you customize that data and stream it out to other places.
Yeah, I think the most important when I see as an implementer, kind of driving this with devs and people who are doing it, we don't want this to be a system where like people remember these patterns and everything and kind of do it on an individual basis. Rather, I think it should be something codified into a system layer where these best practices are kept into the layer, rather than developers thinking about it daily, saying like, oh, how should I handle this? If there's a blob, what should I do, right? Instead, there's a platform which is handling this, and that's where a lot of investment is going in from our side to make sure like these best practices gets codified into the platform, and hence we don't need to repeat these mistakes. And then anybody coming into the team or any new application to be done on this platform, by default get this scale by default, rather than we kind of reinventing that wheel every time. That's how I see the future where it's going.
Yeah.